Hello viewers, in this video I would like to discuss about that as I told last video that Vertex cover is NP complete. So we have seen the last example that confirmed that Vertex cover problem in class NP, and this will confirm the NP completeness of Vertex cover problem. Means we can polynomially reduce if we can polynomially reducible three set to vertex cover problem, and for the proof of this NP completeness we see the following discussion. So let's see. Again, I would like to say you that the reference of this lecture is from the Gary Johnson book, and also some I will mention in some other videos about the references. Okay, let's see. Let's see the instance of tree set. We have u is equals to the Boolean variable x1, x2 till xn, and we have clauses from that is C1, C2, Cm are the clauses, and we know that in a three set, each variable, each clauses will have exactly three literals, and output will be yes if there is a variable assignment such that all the clauses are fulfilled. Now, in this conversion, in this polynomial reduction, if we have such an instance, then there will be vertex cover if we have this three set is satisfied. So here every clauses has C exactly three literals. Now how can we do this what is called constructing of vertex cover problem out of three set? For that we need to have first two things to do. First we need to each variables we need to convert it into two consider as a two vertices and two edges. You can see that there is a picture. The first xi, if I have a variable xi that I'm converting into two literals, and that is the two vertices, and xi and xi var, and then when we are joining the two vertices we are getting the edges ei. Now for every clause ci, we have we introduce three vertices and six edges. So that case, let's say we have Vi is the new vertices for the clauses. As you can see the triangle in the graph, Gi1, Gi2 and Gi3, and that is the Vi. And then if we join the vertices, then we will get this Ei1 first triangle, Gi1, Gi2 is the edge 1, Gi 2 Gi3 is second edge, and Gi3 Gi2 is the third edge. So finally we will add this vertices and edges. We will actually connect in ei double prime, bi and vi double prime, and then we will get yi1, yi1, zi1, yi2, gi2, and yi3, gi3, where ci is my literals, yi1 or yi2 and yi3. Basically, yes, I also mentioned here that basically ei double prime consists of bi and bi prime and bi. So finally what we will get after the construction, we will get that there is a total vertices where we will have a graph. If we consider the total vertices, then the total graph will contain many 2 plus 2n plus 3m vertices for the graph, and then finally we will constructing a graph where the vertices will contain the vi that comes from the variables, all of the vertices, and vi prime, which will come from the clauses, all of the vertices. We will also have the edges from both vertices and both variables, and also from the clauses. So ei is the edge that we get from the variables, and ei I union of I2 is the sum of all of the unions of the edges that we get from this from this converted um, but graph from this instance. Now finally, if the original clauses or three set is satisfied, then there will be a node k is equals to n plus 2m many nodes. So that is the claim. Actually, you can see that in the variable, if we want to cover, then xi x2 bar, we have two vertices. So if I want to cover this, then I will have to have n, and I have a triangle here, gi2, gi3, and gi1. If I want to cover all the vertices in this triangle, I have to cover at least two of the edges. So it is totally n plus 2m nodes for covering the graph in all. So that's all. We have a claim that it can be done in two ways. The claim is saying that if we have a vertex cover b prime of the graph of G, then there will be like size of n plus 2 many nodes, that is k, if the instance 3 was satisfied. And we can prove it in these two ways. We have two methods. The method one is saying that if we have already a graph, then we will pick up the nodes, the covered vertex covered node, and that will consider as a satisfied variable instance, satisfiable variable, and that we can consider as one and no otherwise. This is the method one. And second one is like we have a truth assignment that is already satisfied as three set instance, and we can pick that vertex cover. We can pick that as a vertex cover. Then it is also mentioning as the claim is fulfilled. So in that case, we will have v prime vertex cover is equals to xi, such that the variable assignment of xi will be 1, and xi bar, in that case we will have this phi equals to 0. So we get exactly 1 out of 2 nodes in each vi. So in this situation, we can say it also ensured that at least one of the nodes vi. And finally, we will get a vertex cover that if there is a vertex cover b c, then the length of the vertex cover will be n plus 2m many nodes. If I maybe I will explain later with some example that will make more clear for this claim and method. Thank you for watching this video.